Okay, it's now 1 o'clock, and I think we're ready to begin. Again, I'd like to thank all of you who are joining us on the phones and on the web on today's webinar, the subject of which is Sheltered Instruction to Increase Math Proficiency for English Language Learners. On the call today, we have a number of presenters, and I'd like to remind you that there is a question window on your screen that you should feel free to post questions at any time. My name is Farima Sherman. I'm a managing partner at Academic Business Advisors, along with Mitch Weisberg, who is the puppeteer behind the scenes making everything work. The agenda today includes an introduction to Help Math, an overview from Alan Stern, but the body of our presentation today will be a talk by Lynda Franco, who many of you may already know, and then a further conversation with Marcia Thompson, who's been a very active user of Help Math. We hope time.
Whose is that?
That's my bell. That's the school bell. Sorry.
It's okay.
Well, that makes it real. Thank you, Marcia. That was right on cue. And again, please feel free to post your questions in the chat window. We will try to get as many questions answered during the presentation as we can. But for those of you whose questions may not be answered, we are accumulating them. And we will answer them in a collective email that we will send out to all participants who've registered for the webinar today. So we will follow that question and answer period with a recap from Alan Stern. And I think with that, I'd like to begin with an introduction to Alan. Alan, all yours.
Very good. Well, I want to thank all of you for attending today. This is going to be an exciting session. You're going to hear from, as Farima had said, you're going to hear from Lynda Franco describing some specific examples of sheltered instruction strategies and how they can be incorporated in the curriculum. And then Marcia Thompson, who is a high school math teacher and ELL specialist in Sioux Falls, South Dakota, is going to discuss how her district has used the Help Math program to increase the achievement of ELL students. And just a little background on the Help Math program. It was developed by Dr. Barbara Freeman of Digital Directions International, who is co-sponsoring today's webinar. And the Help Math program came about from the realization that over the last 10, 11 years or so, there's been an awful lot of focus given to reading intervention. However, as we all know, math also has language barriers, and that the sheltered instruction approach could be an effective method to increase achievement in this area. What's unique about Help Math is that it's the first program to take sheltered instruction strategies and embed them in a digital learning platform. So it takes advantage of the benefits of what multimedia provides and combines it with a focus on developing academic language and vocabulary. So what you'll hear about is both some of the basics of sheltered instruction and how it actually can be implemented. And now I think I'd like to turn things over to Lynda Franco.
For Farima, I think you're going to
That's fine. I'll just
Lynda.
do a very quick introduction to Lynda. Those of you who have never had the pleasure of meeting or hearing Lynda speak at various conferences on English language acquisition may not know of her extensive background. Lynda's been working in this field for over 19 years. Her material is covered in lots and lots of presentations and conferences. Lynda is coming to us from a remote location, and Lynda, maybe you can set a little context before you begin. Lynda?
Sure. Thanks very much, Farima. I take it that you're all hearing me. If somebody could, one of the presenters could just type me a note and let me know, yes, we see your screen, that would be helpful. In the meantime,
actually, Lynda, we don't see your screen yet.
You don't see my screen. People have arrived and ready to click the Show My Screen button. How about now?
Yes.
We do now.
Okay. Oh, great. It helps to know which buttons to push. As Freeman told you, I've been an English language instructor for, actually it's been over 26 years, and I teach teachers as well as having my own classrooms now of students learning English. I did teach in American schools. I'm coming to you tonight from Seville, Spain, so it's I'm pretty far east of your East Coast. It's 7 o'clock at night here. And I was teaching in American schools where, you know, as an elementary school teacher, you teach all subjects, as in social studies, science, and math, as well as reading. So I developed sheltered instruction techniques. I have a strong background in that. I moved to Spain because I was here as a student 30 years ago and married a Spaniard, and he wanted to come home. So that's why we're home. So you see on the screen, we're going to be discussing for the next 20 minutes or so what is sheltered instruction. And you see my email, so if in the future, if you should have any questions about what you see or sheltered instruction in general, jot down that email. You'll see it again at the end of the presentation, and I'll be happy to answer questions for you. So let's get started asking the question. Well, let's see, it's not, there we go. The question at hand is, what is sheltered instruction? I just want to note that sheltered instruction is also called scaffolded instruction. Some people call it PSYOP instruction, and I also want to tell you that PSYOP is actually a brand name. It's the name of an observation protocol. That's what PSYOP means, Sheltered Instruction Observation Protocol. So it doesn't mean PSYOP instruction. It doesn't mean scaffold instruction. What it means is any instruction that a teacher gives that's presented in a way so that students can comprehend the meaning of the language that's used. And along the way, they also comprehend the content objectives. Since we're discussing this in a context of students learning English as a new language, we have the experience that we have students who comprehend the math, but it's the language that's the barrier. We have other students that come to us and the language is the barrier, and they don't have the math background either. So sheltered instruction typically employs a lot of multimodal techniques to help students gain access to the content as well as the language. The sorts of multimodal techniques that we're talking about is that we need lots of visuals. Visuals being pictures, photographs, or you bring in the real objects. You also use lots of demonstrations and have lots of hands-on to bring in that math. The reason we're learning math is because we use math in our daily lives, and to show them how we use the math that we're learning in our daily lives. In addition to help students comprehend, we might use some music, chants, or rhythms, but that these should always be accompanied by visuals so that you're not just using words in isolation. Your examples should always be concrete. And when we're dealing with abstract math concepts, that can be a challenge for a lot of us teaching math who haven't really had the opportunity to think, well, how can I make this abstract concept concrete for my students? But that's what sheltered instruction comes down to, asking yourself, how can I present this differently so my students can comprehend? Sheltered instruction also has the premise that you have oral and oral, that's oral being speech and oral being listening. So speaking and listening come before print. So before you read and write, you speak and listen the language so that students will comprehend when they see it in print. They'll have a better background. All of these things used in conjunction with visuals, so the key being that you show the meaning of the language that is being used in order to support the comprehension by your students. So we want to see some typical examples, some samples. I want to bring you to National Council of Teachers of Mathematics, NCTM. They have this guidance statement that's in front of you. It says, as you read it, that math should no longer be presented to students as a mere manipulation of numbers and symbols. I have to say that as a learner, as a child, I know that I learned math by just manipulating the numbers and symbols. I specifically remember being a 7th grader when it dawned on me, something clicked, and I went, oh, 3 times 5 means you have 3 things 5 times. And before that, I just never made the connection. I had just manipulated the math on the paper in front of me. 3 times 5 is 15. 4 times 5 is 20. And I learned what I was told to learn by rote memory, and I got A's in math. But I know until 7th grade, I didn't have a concept of what multiplication was. I was never taught the basic concepts. And as you see here, the second part of NCTM's guidance says that we as teachers also have the responsibility to make math comprehensible to students. So sheltered instruction techniques follow guidance that No Child Left Behind, please, that National Council of Teachers of Math recommend to us. So let's take a look at an example. This is the way I was taught math. Let's see how many of you were taught math this way too. I was taught, let's divide some fractions, okay? I have 1/3, 1 3/4 divided by half. Here it is. So what I learned to do, let's see if this is what you learned to do, or maybe maybe you're still thinking of math this way. I have 1 3/4, so I know the first thing I do is I start here where my arrow is. I start with that 4, and I say 4 times 1 equals 4. And then I keep going. I take that 4, and I add that next numeral on top there, add the 3 to it. 4 plus 3 is 7. So I put the 7 on top, put the 4 on the bottom, and I got the 4 from the bottom of the fraction there on the left. So I turned it into an improper fraction. Then here in the middle, you see, it's divided by, but here I have to remember that I take that divided by symbol and I change it to multiplied by. Then I take the half and I remember that I have to invert it. So that means I turn it upside down. So in the arrow of these directions here, if I turn it upside down, I now have 2/1. So bringing these down, remember I'm multiplying. Bring down the 7/4, bring down the 2/1. And then I just multiply straight across. 7 times 2 is 14. 4 times 1 is 4. Then I remember that that line right here under the 14 means divided by. So 14 divided by 4 is 3. 3 times 4 is 12, so I subtract the 12. I have 2 left over. I put that 2 over the 4. I know I can reduce, so I reduce that to a half. So I get 3.5. My answer is 3.5. So a lot of us learn to do math this way, manipulating these numbers and figures. Just remember the direction to go here, that you multiply and then you add. Don't worry why. It doesn't matter why. Just do it. Then put the 7 over the 4, bring this 4, but don't worry why. Just do it. I never understood what I was doing. Nobody ever could explain to me what this was for. So I looked at the answer one day and I realized 1 3/4 divided by half is 3.5. And I said to myself, wait a minute. I have 1 3/4 and I have half. And the answer is 3.5. 3.5 is bigger than the number I started out with, 1 3/4. So if I think about that for a minute, I'm thinking, all right, let's say I have a candy bar. And I want to share it with a friend. So I divide it in half. So here's my dividing my candy bar in half. The piece that I end up with at the end is smaller. Here's the piece I end up with at the end, smaller than the one that I started with. So how can the answer 1 3/4 divided by half be bigger? And then somebody explained to me, wait a minute, you see, you only had one piece when you started, but now that you've divided it, you have 2 pieces. You have more pieces than you started with. So if you have, for example, 7 candy bars and you divide all of them in half, you see I've divided them in half, and I count them all up, I see I have 14 candy bars. That's more than I started out with. The issue still is, even though I can see that, because somebody's showing it to me now, not just telling me, the issue in division of fractions is that I'm still not asking the right question. So in looking at sheltered instruction, I'm going to show my students what this looks like, and in doing so, I'm teaching them to ask the right questions. So the example I just gave, I have 7 candy bars. I divide in half, but you see, I'm not dividing in half. That's not what division of fraction means. Here's what I had, 7 candy bars divided by half. All of them are divided by half, you see, and I ended up with 14 pieces at the end. But when I say dividing half, I'm not saying the right thing, because what 7.5 means, divided by half means, is how many halves are there in 7 candy bars. And as you can see right here where I've split these candy bars up, you can see as I've numbered them, I have 14 halves. I can see there are 14 halves. So following that same visual representation, let's go back to our original 1 3/4 divided by half. So we're saying that 1 3/4 means how many halves are there in 1 3/4. That's what dividing by half means. So here I have one circle and I have 3/4 of another. I'm going to split each of these down the middle. So now I can clearly see they have 1 half, 2 halves, 3 halves. And then I ask myself, what do I do with this? It looks like a quarter at first, but you have to remember your original question is, how many halves are there? This is half of a half. So how many halves are there here? There's 1 half of a half. So my answer is 3.5. The same answer that I got when I multiplied the fractions out by taking the 4 times 1 plus 3 and put 7 over 4 and then flipped this over and went through all the mechanics of the mathematics. If I understand what this means and I illustrate it, and I've illustrated it here on the computer, I can illustrate it in the classroom by having students actually have circles or have squares, have them cut them in half and have them manipulate these, so not just show them. So for example, what I might do in my class, at the beginning when I want students to understand what math means, and I'm trying to teach them the language and the math at the same time. Typically I have a word problem like the one you're looking at. And what I've done to this word problem is I actually simplified the language from a typical word problem, because I've heard people say before that for English language learners, for math, you know, just simplify the language. Well, I simplified the language, but I think you'll agree that there are a number of kids who don't have a reading level in junior high or upper elementary school. They don't have a reading level yet to comprehend this word problem, just because they haven't had time to, in the instructional process, to reach that level, but I still can teach them their grade level math. I'm going to tell the class, rather than reading this word problem to begin with, I'm going to tell the class, I'm going to show them, I'm not going to tell them. I'm going to show them, and I'm going to have them do something for me. I'm going to show the students that we're going to make kites. I'll bring in a kite, or I'll bring in pictures, of what different kites can look like. Show them flying kites so they understand what kites are. And now I'm going to show them that we're going to make kites. And in order to do this, we're going to have these big pieces of paper. Maybe I'll actually bring in big pieces of paper. Maybe I'll give them smaller pieces of paper to represent the big ones. But here's a pattern for the kite, and here's how the pattern for the kite fits on the paper. I'm showing them what I'm doing. I'm not just putting it in a word problem. I continue to show them that you can see that I can split this paper in thirds. Here I have a third, and a third. So 2/3, these two together, is what I need to make one kite. And for those of you brilliant mathematicians out there that are saying, but what about this corner piece and this piece over here? You could piece those together. Well, we need to fold those over onto our kite. So we're going to use those two. There won't be scraps that we have left over, except this third over here. For the third over here, I can take, when I have 2/3 of a piece of paper and I cut the final third off, I can add those together and get the 2/3 that I need to fit my kite pattern on. Again, showing, not just telling. So I've got my 2/3 that I need to make a kite. So I'm going to show them that I have 15 pieces of paper. And we just said that 2/3 of each piece of paper is used to make a kite. So ask them how many kites I can make. Here are my 15 pieces of paper, same 15, just in a different array. I'm going to show them, I'll split them into a third, all of them into thirds, because we're going to use 2/3. So there, I'm going to use 2/3 of that piece of paper. There's one kite. 2/3 of this, 2 kites. 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15 kites I can make right there. And then I have these pieces left over I can combine. So I'll combine those two for 16, these two for 17, 18, 19, 20, 21, 22. And then I have this piece left over that I have to think about. So I can clearly see I can make 22 kites. Here's my 22 kites, and I have this one piece left over. What is that piece? Looks like a third, but do I really have a third? Because I don't have a third. The question was that I have 2/3 of the piece of paper right here, the red, to make one kite. So the question now is, how much of the 2/3 do I have left over? If I take the 2/3 and I move it under, and take the 1/3 and I move it under the 2, I can see that what I have here, without this piece, of the 2/3, I have 1/2 of these 2/3. So my answer is that I have a half left over. So when I got here and I was counting, what I have is 22 and a half. And I've shown the students, I showed them what dividing by fractions means. As a teacher, I can show addition, I can show algebra, I can show geometry, I can show calculus if students get to that far. So I've started out learning the new mathematical concept. In this case, the concept was multiplying fractions, by being able to see it, by being able to visualize it, and by being able to comprehend it. That's what I wanted the students to do. See it, visualize it, and comprehend it. And as a student, I also understood the language that you used because you showed me, you were showing me divide in thirds, take this third off, compare this third to these 2/3. You were showing me how to do that. And as you showed me, I therefore learned more English language. I learned English structures and I learned English vocabulary, like move this here, take this here, 2/3, 1/3. I learned a lot of vocabulary because you showed me and you repeated. Since I'm limited in the English language, that's a learning objective for me. The English language learners in my class don't just have the objective to learn math, they also have the objective to learn English. So again, back to that original guidance, math should no longer be presented as a mere manipulation of numbers and symbols. Teachers have the responsibility to make math comprehensible. Teachers might ask me a question, or students, since I learned to visualize this concept to solve the problem, why should I bother to learn the calculation? Why should I bother to manipulate those numbers and symbols? Well, the guidance for teachers says it shouldn't be presented as mere manipulation of symbols. It means in addition to learning to manipulate the numbers and symbols, they should also learn to comprehend what it means. So then teachers might ask me, well, if they can just visualize it, why do I have to bother to teach them the calculations? This is more a student question, actually. Visualizing works fine when it's small numbers, like the ones we've done. 1 3/4 divided by half. How many halves are there in 1 3/4? Or 15 divided by 2/3. How many 2/3 are there in 15? Things like that. You can teach students to visualize that. You can just see that in your head. But once you get into bigger and more complex numbers, to an 11/16 divided by 7/18. How am I going to see 7/18 of an 11/16? Or 4 and 5/24 divided by 1 and 16/33. It's quicker, easier, and smarter to figure out problems like these mathematically. Because I just can't, I don't know how many 16/33s are in 5/24s in my head. I can see halves and 3/4 in my head. But the idea is that when it comes to those large complex numbers, they still need to learn the calculation part, but when they're dividing those, they have the concept of what they're doing in their heads. They're not just manipulating the numbers and the figures. So they will be able to comprehend what they're doing. Why should I teach them to be able to see math, see it in their heads? Why shouldn't I just teach them to manipulate the numbers and symbols first? Well, this comes down to an English language learner sheltered instruction question, because for the English language learners, using the visuals and manipulating in those concrete examples, it helps them comprehend what you're saying, because you're showing what you're talking about what you're showing. So they can comprehend what you're doing. Without doing that, English is just sound and noise. It's just, you're the Charlie Brown teacher going wah, 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 wah in the back of the room, because I don't know what you're saying. You're not pointing to a picture that shows me what this particular wah means. But if you're pointing to a picture, suddenly the sound has meaning. Written English is just squiggles on the paper if I can't say it and understand what it said to me. So I need those visuals and manipulations first to be able to comprehend. For the English language learner, students are comprehending math and learning English at the same time. They're learning the mathematical calculations to extend their concepts. So sheltered instruction, again, is that instruction, it's the way you instruct that helps students understand not only the language but the content objective in your instruction. And I know a lot of you are saying, hey, a lot of our textbooks now are doing what you're saying. They're using these demonstrations, these pictures. They're in my teacher's manual. It tells me to to give students pieces of paper and have them cut it up. Exactly. That's because many of the publishers know that this is what the guidance from NCTM is telling us, and we want this as teachers. But many teachers, particularly if math isn't your specialty area, many of us in middle school we're math specialists, but maybe in elementary school we teach math and science and social studies and language arts, but maybe I'm a reading specialist and I teach math and science because it's in my curriculum, but I'm not a real math specialist. So for me, since nobody ever taught me to think about math this way, it can be a little more challenging. And sheltered instruction in the beginning can be a new way of thinking for many of us. I've had teachers tell me who've been using the HELP program that they look at how the math program shelters the instruction, shelters the language, the math language, and they say, oh, this gives me ideas of how I should be teaching this, because I could use these same visuals in my classroom to get these ideas across. Again, students understand your content and your language because you have sheltered your instruction. If you have questions about sheltered instruction, type those in there. But that in general, for math, what sheltered instruction can look like. Again, you'll do the same thing when it comes to addition, when it comes to multiplying, just basic facts, when it comes to percentages, when it comes to decimals. You look for the same ideas, ways to show what you're talking about, through illustrations, through having students actually do these things.
Lynda, we've had a couple of really good questions, several really good questions from our listeners. And the first really has to do with, we talked a lot here about NCTM standards, but a lot of educators are very
That's just to make sure everybody's awake.
Love the school bells. It really creates a realistic environment. Is Common Core requirements, and I was hoping that you could address that question from one of our listeners. How does sheltered instruction support or work in concert with the requirements for math and Common Core?
The teaching requirements, it doesn't matter what the teaching requirements are, whatever you're asked to teach, you shelter the meaning. So you think, regardless of what I'm teaching, in other subject areas as well, but specifically in math, if I'm teaching probability, I'm going to show students before I teach them to just manipulate the numbers and symbols, I'm going to show them what it is they're figuring out in this math. What do I need to know? That's why the math program always starts with a real-life scenario, because we want students to understand that you're learning these math concepts so that you can figure out things in your real life that you need to know. The Common Core standards are the basics of math that you need to learn. Well, if students don't have the basic number sense or the basic concept of whatever they're learning, then it's harder for them to build on the core and continue. So I'm just saying, whatever your Common Core standards are, you show those concepts. You look at your teaching objective and say, how can I show a student what this means? Not just tell them and not just represent it through numbers and symbols.
Well, one of the challenges that is being addressed during the common assessment is a way for students to demonstrate an understanding of the concept, not just an understanding or a correct answer. So
and if it's presented to them in a sheltered way, they can present it back showing that they've understood, because I wouldn't go on with the math until they could show me that they understood the basic concept. I wouldn't go on with manipulating numbers and symbols until they show me they've understood the basic concept. So, drawing pictures and so on.
So, Lynda, some of the concepts that you talked about were very practical visualizations of very concrete concepts. At what stage are students able to grasp things that are a little bit more abstract, and is that done as well through sheltering?
Their ability to grasp abstract concepts doesn't really have to do with their language development. It has to do with their cognitive development. So pedagogically, we consider children between 6 and 7 years of age, that's when they're old enough to grasp those abstract concepts. The issue that we're dealing with is I have 12-year-olds who have the cognitive ability to grasp abstract concepts, but they don't have the language to understand what I'm talking about. So I have to show it to them in a concrete way first in order for them to be able to think about it in abstract terms later. So the English language learner that's over age of 7 is perfectly as able to put something in abstract thought as any other 12-year-old is. It's a matter of waiting for their language to catch up so they can express their thoughts in English.
Well, that's very helpful. We had another question, but I think you really did cover the importance of academic vocabulary. We've focused a lot here on mathematics vocabulary in particular. What other tools besides pictures can be used in sheltered instruction? Do you use props? Do you use audio? What other reinforcement?
The three major kind of visuals are pictures, props, and the real thing, realia. Bring in real apples and have them cut them up. Bring in a real orange and have them count how many sections and make probability guesses of what's the probable number of sections in this mandarin orange. Or doing demonstrations where the teacher is the one showing and then having the students follow up with a hands-on activity. Those are very typically the way that I get meaning across. I do use a lot of gestures, a lot of nonverbal cues, like pointing and acting things out. Those are demonstrations.
That's really helpful. And I'd like to also thank Lynda Pritchett for her comment about the kite example being a concept in the Common Core at 6th grade level. So it's always wonderful when one of our samples hits a sweet spot. So thank you again for that comment, Lisa. If you have any further questions for Lynda, or if questions come to you afterward, it would be wonderful if you would send them to us so that we can share them with all of the participants. You can do.
Could I say? Oh, I'm sorry.
Go ahead.
Farima, I wanted to say one more thing.
Please.
I would like the participants to be assured that sheltered instruction takes time and practice to learn how to execute. The beauty of the help program is that the instruction has been sheltered for you, for your English language learners. So if you're just starting out in the area of how to shelter instruction, you get some ideas from the help program, but it's sheltered for you. Thanks, Farima.
Well, thank you, Lynda, for those wonderful comments. And we'd like to move to the next speaker, who can talk a little bit about very practical applications. Marcia Thompson with Sioux Falls School District is an ELL math instructor who's been using the help program, and we'd just like to get a little bit more insight from Marcia. So good afternoon, Marcia.
Hi, how are you? And how is everybody? I hope everybody's having a good afternoon.
Well, it's great to hear your voice and get the benefit of your experience as well. Can you start, Marcia, by setting a little context and telling us a little bit about the Sioux Falls School District, its size, its population, et cetera?
Sure. The Sioux Falls School District is located in Sioux Falls, South Dakota. It is the largest city in our state and is the largest school district. Our school district serves around 23,000 students, and of those students, around 1,800 of them are ELL students. At my particular school, at Lincoln High School, we have 113 of those students presently. With all the numbers that we have in our district, the ELL students that we have are very diverse. We have over 50 language groups, different language groups represented, and we are a part of the WIDA consortium that provides testing for English proficiency. So when students come into our district, we have a immersion center based place where they go and they test, and according to age, students are sent out according to where they live and how they test, where they enter into our immersion program, if they are high school age, if they enter our immersion program, or whether they enter into our sheltered program when they come into our district. Each of our high schools, we have 3 high schools in town, each of our high schools has an immersion center for those who are just beginning to learn English, and as well as sheltered classes to help those who have increased their language proficiency but still need the added help of learning language and content in an intentional way.
Could you explain what the WIDA consortium is, just a little bit?
WIDA is a group of states that have come together and actually have partnered together, and it's a way that we're using this particular group. They have set up what is called the access test, which we use for our proficiency testing that we have to do every year for the federal government requirements.
Thank you. It was not a term that I was familiar with. I don't know if the rest of the audience or listeners were familiar. The challenges for ELL students in gaining proficiency can be very many and varied, but there are some very specific problems from district to district. I wondered what the issue and challenges were that you were trying to solve with the use of the HELP program.
When we first started to write out our curriculum, one of the things that we found we were still lacking was finding a thing to help assess students when they came in, and a gap filler for those students who were not ready for high school math. And so I started looking around and just happened across the Help Math on the web, and was very interested in and looked into that, and we started looking at that as a possibility. And our goal was to really look at that as a way of helping those students to be able to have a tool for those students who needed that individualized instruction in areas where they were really weakest. And we really were impressed with the fact that it did emphasize language learning as a key part of the instruction.
And so your background is in both ELL and math.
Right.
What was the process for implementing in your district? What did it look like?
We started the Help Math program in our high schools in the district, not this past year, but the year before in 2010, 2011. And prior to using the program, teachers from each of our schools were trained in how to use Help Math, and then we used it as a tool to supplement our math curriculum that we already had in place. We use it especially with our immersion students at our school who come in at any time in the school year and must be blended into our classroom. And so it works out really nicely, because I can have a student that will come in next week. They can just show up.
And as far as how it's physically being used in the building, is it used in a lab setting? Is it used on whiteboards in class, at home? What kinds of usage scenarios do you see?
Okay. We use it several different ways here in my school. Students primarily use it individually at my school. I have a mobile lab in my room, so I have laptops in my room. At the beginning of the year, I give each of the students actually take the pre-assessment that Help Math has available, and creates a custom curriculum for each student. So it shows each student their particular weaknesses, and it creates their own curriculum for each student. So each student will have their own particular set of lessons that they will go through. So if one student is maybe strong in one area, then they won't get to that lesson, but somebody else may not be strong in that particular area, and they might get, they might be strong in fractions and they won't get that lesson, and someone else might not be and they would get that lesson. So so I have it mainly as an individual, but I have also used it with our smartboard in our room, so I will use it sometimes as full class instruction when I find that it's sometimes I find that that's a great medium to use. I like some of the ways that Help Math has examples, and so sometimes I will pull that out and use that as full class instruction. And I have about a third of my students who have internet access at home, and they will do it at home on their own time as well. So it's worked out very nicely.
It's interesting because one of the home uses that we hear about sometimes are other members of the household using it as well as the students from school. So I don't know if you're seeing a whole lot of that, but
I haven't yet.
We've been hearing some cases of that, so it's kind of fun to hear about. Now, the teachers who were trained, what was the process? What was their reaction? How easily was it incorporated into their teaching day?
I think for most of us, it has worked out really nicely because each of the high school has sort of a little different twist in how our programs are set up, just simply because of the numbers at the different schools. One of our high schools has more ELL students than we do, so they have more ELL and math instructors. I'm the only ELL math instructor at our high school, and the other high school only has one as well. So we have sort of different ways that we use it, but I think for as far as the way the program is set up and being prepared for it, I think we're all of us are trained as ELL instructors, and our focus is to have that it's really important. I can't stress how important it is to have a language objective, and that is just really, really key. We can. No, if you have the math objective, that's fine, and that's what we are. We are math teachers, but we also need to have a language objective every day, and we need to be very intentional about what that objective is and making sure that we are assessing that one as well. And I think that's really a real important key aspect of what Help Math has really helped emphasize and helped my students understand how important it is that they learn the language of math. A lot of them are very, some of them have very good computational skills, but they have to still find ways to be able to express that in English, and having to help try to catch that up with what they can do is very important. And the Help Math has many of the features of a lesson that we want with scaffolding, much of what Lynda talked about earlier. And it has that modeling and the guided practice and the independent practice. It has that comprehensible input that's so important for students so that they can understand what they're hearing in English. And being able, and even the process that I know some of my students will actually listen to something over and over again. They can listen to it again and again and again so that they actually can hear things multiple times. And I think it's just super important that we really stress how language is a real key factor in all of this, and how we want our students to be able to gain that proficiency so that they can move on to mainstream classes. That is my goal. My goal is to move them to mainstream classes as quickly as I can, but at the same time where they can be successful.
Well, you mentioned earlier that you had students from with 50 different languages. How is it used with speakers of other languages who aren't Spanish speaking? Have you found it useful throughout?
Yes, it's actually been pretty useful throughout. I mean, it is a great asset and a great tool for those kids to come in that are Spanish speakers, but that is not our main language is not Spanish speakers. We have a lot of students that are coming to us from Iraq, and we have a lot of coming from Nepal, Burma. We have a lot of students from Africa, so a lot of our languages are not Spanish, and but they do like the program, and they do like listening to it. And I think they are able, by listening and being able to see the pictures, the words being underlined, those kind of things really do help, because it's like we know, ELL students need to hear words in context, multiple times in order to be able to learn that word. They have to have 50 plus times of hearing a word before it sticks, and that's a lot of times. I can't say it, I can't say it enough in the classroom. it has, we have to, constantly give them opportunities to be able to hear words in context with meaning for them to understand new words, academic language that they need to be successful.
So as they strive for success, and as you're trying to ascertain if they've really mastered the language concepts as well as the math concepts, how have you been using the reporting functions, and what have you found to be particularly useful in the reports and assessments?
You can find any kind of report, which is really great because it's really interesting within our, when I have students working on Help Math, I'll have a few students, like any other classroom, you'll have students that will get off task, and I can always tell them, well, I can tell when you've, how long you've been on. It reports the number of minutes they've been on, what part they've been on, what did they stay on instruction, what part of the map of the particular part of the program have they been listening to? Did they just jump to the quiz and forget to listen to the instruction? I can see exactly what students are doing, which is really nice because I can't be everywhere all the time. So it's really, that reporting part is really a nice part, but it also is great because you can also pull off data when you get done. At the end of the year, it's great for us to be able to pull off data and find out what improvements you really have had.
We had a question from the listeners about your courses in particular. Are graduation credits applied to the courses you're teaching for ELL? Okay.
Yes, they are.
Yes, they are?
Yes.
Oh, that's great.
It's in flux now because of Common Core.
As is
Everybody's in flux because of Common Core.
That seems to be a pervasive.
Yeah, it's a pervasive thing. When I saw that about Common Core, I was like, oh, okay, yes, other people are struggling with it too.
So your experience couldn't have been all peaches and cream. So
no, it's not.
So what were the issues? What were the challenges as you were implementing help?
Okay, the biggest challenge I think is like we have with any kind of classroom and with any students. You have students that like Help Math and you have students that don't like Help Math. And those are kids, they're just like any other regular kids. You have kids who like to be on a computer and like that visual and like that and like being on a computer. And you have kids who don't. And I have a mixture of those. I have kids who would be on Help Math every day, all day, and would tell me to shut up and sit down. And then I have kids who would rather hear me talk and help them. And so it's a, there's a wide range of what, kids like. And so that's probably been the biggest thing is, kids' preferences and having, some days kids have to do things they don't like. So, some days they have to do Help Math and they don't like it, but then some days some of the kids who would like to do Help Math have to listen to me. So it's sort of a trade-off.
I'm sure that's not the chore you make it sound.
No, it's not. I hope it isn't for
So how have your students been doing in general with AYP?
Doing fairly well with AYP, yes.
Great, and you're seeing that district-wide as well, I bet.
For the most part, yes.
Great. That's everyone's challenge is meeting those AYP goals.
Yeah. We every once in a while miss by maybe like one student.
And your plans for the ongoing applications of HELP or any other programs, your ELL math students?
Say that again?
What are your plans going forward?
As far as we know, we want to continue to use Help Math. I'm hoping that we continue to use Help Math. I think it's, for me, I think it's really important, especially as we move toward Common Core. And we right now are in the midst of a math study ourselves in our district. I think it would be very useful I know it's very useful for me in that for those areas that students are weak in, I know I can send them to the part they need to do, and I can find it in Help Math because it's there. It has, and they've matched up to Common Core. Now, obviously, it's not going to match up to high school standards for Common Core. So if that's what you're looking for, it's not going to do that. It matches up to K 3 through 8. It matches up to grades 3 through 8. So it's not going to match up that way. But we need those things. We need the extra help in the classroom. So this is a great supplement for us, math teachers who need that extra background material and supplements to help get our kids ready for what's going to be asked for them in Common Core.
So this has been wonderful and very insightful, and we thank you so much for sharing your experience with the group. I will share with the listening group that we are doing our best to record this session. So we're hopeful that we will be able to make this. There we go. Which is great. But ask if you have any further questions or issues that you'd like to have clarification on. Please do email or chat them, write them into the question window. And at this point, I'd like to thank all of our speakers, particularly Lynda and Marcia, for their contributions for all of our behalf. And I would like to turn this back over to Alan Stern.
Okay, thank you, Farima. Well, a quick recap for everybody. We had the opportunity to learn about the implementation of what are essentially best practices for students struggling to achieve math proficiency. And you should have seen how these research-based strategies, and that's important to keep in mind about sheltered instruction, that those strategies that comprise sheltered instruction provide a proven method to support classroom teachers in delivering instruction that both engages students. I was especially intrigued by the kite example. I'd never seen that before. That's got to be a great activity. From Lynda, I think it was clear about the importance of not only academic language and vocabulary, but the visual aspect of math for clarity, and the importance of being able to see, hear, and understand the concepts, and why all three of them are important to the comprehension of the concepts. As Common Core standards are dictating now, we're way past memorization and simply the oral approach to math. Marsha's examples, I think, were very good. You got to hear a real-world example of how a sheltered instruction program like Help Math is applicable to all her ELL learners in a variety of ways, and it's very flexible to whatever the classroom teacher wants. I think one of the most important benefits, if you will, of Help Math is that it provides a way for teachers to implement sheltered instruction seamlessly. That, as Lynda mentioned, that sheltered instruction and implementing it can be a challenge, especially given time constraints in school. But using Help Math, there it is. There are your sheltered instruction strategies already embedded into the content. So with that, just a couple of things. If we didn't respond to any of your questions, or if you still have questions that you would like to address to us, we'll do our best to provide a written response. For more information about implementing sheltered instruction or about the Help Math program in particular, as you can see on the screen, the website is listed. If you have specific questions or that you'd like answered, helpprogram@comcast.net is our email address, and we are very responsive. We do get to you very quickly. We want to thank Lynda and Marcia for their insights and experiences, and we want to thank all of you for participating today, and appreciate your time. And this does conclude the webinar. Thank you.
Okay, and just, Lynda, this is Mitch. If there's a way that you could email me your PowerPoint, because a number of people have asked for it.
Absolutely.
That'd be
Absolutely.
And let's not forget to thank DDI for their sponsorship of this event. So to the staff of Digital Directions International, thank you again for your support in putting on this wonderful event. Thank you.
Okay, thank you, everybody.